Newberry. Let's talk about nanotechnology. Nanotechnology, as you probably already know, is the ability to observe and measure and create at the molecular and atomic level. That means building things and manipulating things that are very, very small. In fact, 10 hydrogen atoms, if you could get them to behave themselves and you could line the hydrogen atoms up in a row, that would be 1 nanometer long. So a nanometer, a size length of a nanometer, is very, very small. So nanotechnology is dealing with the world, biology, chemistry, physics, the world around us at the atomic or molecular level. And one of the things that is very important about nanotechnology and our ability to apply it to things like catalytic converters, sensors, measurement systems, even diagnostics and medical supplies, is the fact that surface area is so important for defining chemical reactions. In fact, the little bumps on our tongue create a surface area on our tongue that is equal to about 200 square centimeters, a whole lot larger than what our tongue actually is. But because of those bumps, the tongue has the ability, we increase the surface area of the tongue, therefore our sensitivity to taste, like salty things, spicy things, sweets, is enhanced, and we have that ability to taste because of the surface area of our tongue. So I have an activity that I'd like to talk to you about where you can investigate the impact of surface area. And what you're going to do is you're going to dissolve some effervescent tablets in water and measure the time that it takes them to dissolve. And so what you're going to need for that experiment, I have here on the wall, you're going to need about 6 to 8 Alka-Seltzer or effervescent tablets. Doesn't have to be the Alka-Seltzer brand, can be a regular generic brand, but you want those effervescent tablets that we a lot of times used to use to treat a headache. 6 to 8 of them. You're going to need around 4 clear cups, pretty much all the same size, because what you're going to do is you're going to put the same amount of water in each one of those 4 cups. And then you're going to need a ruler or a pair of calipers if you want to get really fancy, a stopwatch or some sort of timer, and some paper or a computer to keep track of your results. What you're going to do in this experiment is you're going to take those tablets and you're going to break them up into different numbers of pieces. And then you're going to take each one of those batches of pieces or a whole tablet, or you might even choose to grind a tablet up with a mortar and pestle into a powder. So what you will have is your tablets, a whole tablet, maybe a tablet broken into 2 pieces, maybe a tablet broken into 4 or 6 or 5 pieces, and maybe the powder. And you're going to take each one of those and drop them into the water in each one of the cups. And then you're going to time how long it takes that particular tablet, in however many pieces you may have, to dissolve. So that's what you're going to need. You're going to need the tablets. You're going to need 4 or so clear cups with exactly the same amount of water in them. You want to use a measuring cup, a ruler or calipers, because we're going to need to measure the size and the surface area on each one of those tablets, a stopwatch to time how long it takes that tablet to dissolve, and a piece of paper or a computer to keep track of your results. Maybe you can remember 4 or 5 different results, different numbers. Sometimes you can't. So it's always a good idea to have something handy to document them. So let me get my tablet and I want to show you what I'm talking about. Here I have a tablet, one of those effervescent Alka-Seltzer tablets. And that's the thing that I'm going to dissolve a whole tablet. I'm going to break another tablet into 2 pieces and another tablet into 4 pieces and maybe grind another tablet up. And that experiment, I'm going to calculate the amount of time it takes to dissolve. Now, I've given another example to your teachers of how you can take some of that data and actually predict the amount of time that it might take a tablet with a different number of pieces to dissolve. But right now for this video, all I wanted to do was outline the basic experiment for you and let you have some fun watching these tablets and different numbers of pieces dissolve. It's pretty easy to do, and it shows you the importance of surface area. You might be going, well, just exactly how does that show us the importance of surface area? Well, every time you break this tablet into a different number of pieces, you're increasing the exposed surface area to the water because you're breaking and you're creating new edges that are now exposed to the water. And what you're going to find is that the time to dissolve for the different numbers of pieces and the powder is significantly different. And that's because the surface area in each one of those examples of those tablets in each one of the cups is different. So good luck, have fun, and if you aren't quite sure how to measure or calculate the surface area of each one of your tablets, watch that next video. Thank you.